Hello and welcome to the Human in the Machine podcast, the podcast about all things HCI. As ever, I'm your host, Professor Ben Cowan. In this episode, we have the chat I had with Professor Andrew Howes about his work on collaborative AI. We touch on a lot of areas here in the chat, including the role of modelling in HCI, trust, and what collaborative AI might be like in the future, with a few laughs along the way. Again, if you like the podcast, please don't forget to review and follow us. And if you want to get in contact with us, you can by emailing us at humaninthemachinepodcast@gmail.com. Again, let us know what you think of the topics, if you've got any ideas for speakers, if you just want to hear from us or just leave a message, all will be welcomely received. Without further ado, please sit back and enjoy. First of all, thanks very much, Andrew, for joining us today, and thanks very much for the talk as well. First thing I wanted to ask you is, you got a really nice perspective on aspects of using user modelling to understand human behaviour. So what brought you to that topic? What brought you to thinking that that was an excellent way forward for understanding behaviour?
The first reason is that in 1984, I graduated from university into recession, but I was fortunate enough to get a job offer from IBM, and I was very excited about that. But they sacked me before I started, and they sacked me because it was actually that was around the time that Microsoft, the first IBM PC had come out, and they decided that all the money was in the hardware and not the software, and so they outsourced the operating system to Microsoft, which was a completely new company at the time. And then they discovered Microsoft were making millions and IBM were losing money on every piece of hardware they shipped. So they cancelled their entire global recruitment at that time. And so I was left without a job. And the only thing I could find to do was a PhD. And I didn't want to be an academic. God,
how did that work out for you?
Yeah, how did that work out? So, life's full of forced choices. You've got to be opportunistic, make the best of what comes along. But I was interested in educational software. And so some of the very first AI systems that people really tried hard to work on were systems that helped children learn mathematics, and that's what I found absolutely fascinating. And fascinating because they were very simple AI systems. What you would do is you build a big rule base of all the possible the rules that you need, for example, to do arithmetic or long multiplication, and these rules would perform arithmetic in the same way that children do. And then you could add what were called buggy rules in to the database, and they could be selected to model individuals. You could model individual skill deficits for children. And then once you've got that model, you could try and figure out what set of problems to give them to correct this bug, so that they get rid of the buggy rule. And some of you may have used these systems. You may have used some of these early educational systems for learning arithmetic. I don't know, they are out there. I don't know how widely they're used now, but they were sort of reasonably successful, I think, but very, very primitive. And so I started to think about how you might use more sophisticated models in learning, and got increasingly interested in cognitive science from there. So.
Yeah. It also seems, because it seems like such a wonderful approach to try and understand why people, in terms of choices, but also in terms of behaviours. And I'm wondering where, especially in terms of the role of HCI, where you feel models fit, or do you feel that there needs to be more of a role for that view of models trying to understand user behaviours within HCI? So where do you see that as a tool that we use in the HCI toolkit? I think it's a fascinating tool as well. I've been fascinated with since meeting you in Birmingham. But I wonder whether you feel that as a community, should we be engaging more, and where do you feel the place of it is?
Okay, so as you will have come to see already on your course, HCI is extraordinarily diverse. You've got cognitive scientists, you've got computer scientists, sociologists, business people, healthcare people, medical people, doing all sorts of different things, different approaches to HCI, studying the microstructure of interaction and also the impact of an adoption of computer systems in whole industrial sectors. Work practice, legal approaches to the governance of technology, all sorts of things. And one tiny part of this broad spectrum of HCI is modelling. For me, it's really an important aspect because it gives a robust theoretical underpinning to what should be the whole discipline, in the sense that at the heart of HCI is the immutable aspects of the mind, the cognitive system, where we all interact with machines by processing knowledge in our heads, and that in the end is for all of the changes in our systems and societies and work practice and etc., the one surefire fixed point is what we are as humans, as information processing systems. So that's why I think it's foundational. It doesn't mean say everyone has to do it, and it doesn't mean that if you are engaged in a design project, I wouldn't say the starting point or any point that you should necessarily be doing cognitive modelling, but it's like the mathematics of HCI for me. It's kind of the core robust centre point that, as a science discipline within universities, it's the thing that we need to be doing to generate real substantive knowledge in the long term.
Well, I think also the way cognitive modelling and user modelling plays with cognitive science and HCI in the same sense. How do you feel that they link together? Do you feel that they speak to each other as disciplines?
Yeah.
And how much do we engage with cognitive science as a discipline, do you think?
Okay, so here's this perhaps answers this question and the previous one. Does anyone know what distributed cognition is? The idea of distributed cognition. Have you come across that term? You do. Anyone else? Yeah? You have, yeah, a little bit. The idea is you make full use of the resources in the environment. So you get this kind of more sociology of cognition, of interaction, where you can think about how. I'll give you a specific example. One specific example is in a cockpit when say like with a micro light airplanes. It hasn't got all of the sophisticated systems, but it's got for example an altitude altimeter, right? And what a pilot will do, they have what are called bugs on this thing, which are little things they can slide around to fix points on this. So if they've been told to descend to 3,000 feet and they're at 5,000 feet, they'll set the bug to 3,000 feet so that they don't have to remember in their head. Instead, they distribute the cognition to the environment by putting a little memory note, effectively. And in fact, the whole system is designed to do this, so that the 3,000 feet is recorded in their world, in their immediate task environment, and then they no longer all they ever do is descend to the bug, not descend to 3,000 feet, right? So it turns out that in this sense, we distribute cognition all of the time. People, right? We make notes, we reorganize things, we think, I mustn't forget. And I said earlier, you've all got better memories than me. If you don't do these things now, you will do them as you get older, right? When I'm getting ready to go to work in the morning, I have to put everything that I want to take by the front door. Otherwise, I will not remember it, including the front door key, right? Everything has to go there because it's got to be in my visual system. It's got to be in my line of sight for me to remember it. Otherwise, it's gone. And if people say things to me, don't forget to do X, I found that I was quite often just going, yeah, okay, I won't forget, which meant I will forget, because there's absolutely no way I'll remember it unless I actually make a note of it in an appropriate place where I will see it. Not where I look for it, but where I'll see it. So So we make use of our environment for memory as one example of distributed cognition. And actually that idea in distributed cognition there's nothing wrong with that. But one idea that became very influential was the idea that we're cognitively lazy, that we routinely distribute things to the environment when we might not need to. Now, what cognitive modelling has shown is that that's definitively false. We wouldn't be able to get by in the world if the explanation was that we were cognitively lazy. The answer is we're not cognitively lazy. The answer is that we're adaptive. So we distribute to the environment to the extent that it helps us perform our tasks better. If we were lazy, we'd be all the time doing these things and never trying to actually encode and remember things, and we wouldn't be able to get by that way. So Kenten O'Hara's work demonstrates this on a broad range of tasks. So that's I've forgotten what your question was now. Does that answer the question?
As well as the keys, as well as everything.
Right. So this is an example where so you don't do cognitive modelling in a typical design exercise, right? So a client might come to you and say, "Can you design us a system that does X, Y, and Z?" And you say, "Yeah, sure." You're not going to start doing cognitive modelling, but in the science base and through the educational process, it's cognitive modelling that gives you robust knowledge about how people behave. Can I give you another example? I just have another one. Imagine that. So we worked with a company. So I do cognitive modelling when working with companies as well. We worked with a company called Pt2, a Portuguese company, who do credit card fraud detection. So their computing systems analyze data from millions and millions of transactions a day across the whole of Europe. And the computing systems, it's a human in the loop AI problem again. Their computing systems flag transactions that might be fraud. And this is high pressure, has to be very fast processing. So that someone's waiting, they're paying with their card at a till in Milan, new handbag, $3,000 something. And then this gets pinged to Pt2 in Portugal, and they say, and the system says, "Not sure about this transaction. Can you have a look at it?" And then they have a human analyst who looks at it, and they have to go through lots of data, lots of attributes of the data. So transaction history of this card, it's the home address, and et cetera, the amounts the amount of the transaction, blah blah blah, 10, 20, 30 dimensions of the data. And so the problem Pt2 were having was their analysts were taking too long to look through all of this data. Methodically, eye movements, gathering the data, and then making a decision. And so they said, what can we do about this? And the first thing we did, being who we are, we built a model of this, and to look at the information gathering process of the human analyst. And then we looked at variations of the interface. And one variation we looked at was at color coding the information rather than just using textual presentation. Thinking that would speed up the information gathering. So you look at a colour, more quickly rather than reading the numbers. That was the idea. And then when we ran the model and we let the model adapt to our new interface, it did something we didn't expect. It discovered a strategy that we didn't expect, and that strategy was not to even fixate all of the colours individually. It could just look at the middle of the pattern and see the whole pattern in the colours holistically, which it couldn't do with the text. And the reason for that was that at sort of 5 degrees of eccentricity from the fovea, its colour detection was good enough to pick the pattern up, but its text reading capacity at 5 degrees wasn't good enough to read the text. So it used fewer eye movements to pick up this whole pattern at once and then be able to go, bang, okay, I can make a decision. And so then Pt2 can take that through into their design practice and speed up the analytic process. So these models, when you have adaptive models, they're using machine learning to learn policies, they can make, and you see this it's not in a design example, but you see this in DeepMind's Atari software. So their deep reinforcement learners discovered strategies for playing Atari and for playing Go and chess that no human had ever discovered. And they can do the same in HCI, and therefore point us towards designs that facilitate those strategies.
And I think that's one of the one of the fascinating things about using the approaches that you were talking about initially, where you were looking at those kind of approaches where you don't necessarily need human data to be able to build those models. And I'm wondering where, especially from presenting that there today, and we've had conversations about this beforehand, where you feel that human data is best placed whenever trying to understand human behavior, as well as where those empirical and experimental work come in that pipeline.
Yeah. It's crucial. You can't do modelling without the data. The first point at which the human experiments and human data are crucial is in inspiring the models. So that the decision-making model that I described to you, which uses this contextual preference effect, that's an extraordinary effect that I think was first observed by Kahneman and Tversky in the 1970s, maybe in the late 1960s. And they just had an intuition that somehow that people would exhibit this effect. Where did that intuition come from? Actually, I haven't traced back. There may be some history to find it, but somewhere someone's had an idea, and not by modelling things in a computer system, but just by thinking and observing people. Someone's had the idea. You know what? I think this choice context is going to make a difference to how people make choices, and then they built an experiment. Because the idea is ideas are cheap, right? I mean, in some sense, it's extraordinary they had the idea, but most ideas are wrong. So then they need to do the experiments to show that the idea is correct. And designing experiments is really hard, and to get them so there aren't confounds in the experiment, they're robust. Conducting them is really hard. You've got to get all the participants, and participants don't do what you want them to do, and they're annoying, and they take time, and etc. And you've got to get the data, you've got to do the analysis. So all of that, our work, our modelling work, is parasitic in many ways on this fantastic experimental tradition. So that's one thing, but quite often, in my experience, so psychologists do this, and I'm a psychologist as well. I've taught psychology for 10 years, but quite often the explanations that psychologists give, the verbal explanations, are wrong. They're not actually very good, I think, personally, at explaining the data. They're very good at generating data and intuitions about what people might do, but the deep explanations are I think, almost impossible to generate without computer models, because the systems are just too complex. And so that's where the computational modelling comes in. Now, once you've built the computational model, and you need to show that it explains the data, but then you need new data. It will make new predictions, like the feed site one. Well, there were no data for that. So then we need to go and gather human data to show that people really do what the model's predicting. So the experiments, the data, and the analyses are playing two roles.
And that seems to be a critical part of that as well, those elements of the validation process, because from what you showed, especially validating Fitts law based on the fact that the models didn't necessarily have any human data to be able to build, and then highlighting that the actual behavioral data is there for all to see, that the model does something incredibly similar. So that I think it's an incredibly powerful way of showing the power of models and the power of doing those things. I think when looking at, especially how you pitched your talk there about the idea of collaborative AI, and so I wanted to kind of bring in a little bit more around that topic, because it's such a hot topic at the moment, and I think it will be in the future. I'll be asking you about that in a second too. Especially when it comes to more complex or social-oriented goals, where do you feel how these models can work in that type of space, or when the goals are shared but maybe not as clearly well defined?
I don't see. So I agree. Those problems are fascinating, and there's a lot of research that we need to do on them, and that the certain kinds of social norm will play a role as we observe in things like the ultimatum game, and there's all sorts of experiments that show that people behave in ways that are conducive to encouraging cooperation in society. I think all of those, in the kinds of model I've described, I think all of those things can be encoded in the reward functions that constrain the models. But I haven't demonstrated that. So we do have a project at the moment that's funded by Turing and by the US Army, which is looking at It's trying to understand teamwork through the lens of a game called Stag Hunt, and in the Stag Hunt game, it's a very simple game. It's like Prisoner's Dilemma, but you've got two hunters. We're two hunters. And we can
the least likely to hunt.
the most incompetent hunters in the world. And we're going to go into the forest today to hunt, and we can choose to take our spears to go and hunt the deer, or we can choose to take bits of the trap to go and hunt rabbits. The deer, obviously, getting a deer is much more valuable than getting a rabbit. But we can't negotiate beforehand. But it's an iterated game, and if we're going to hunt the deer, we've got to choose independently whether we're going to take our spears or not. So if we both take our spears, then we can hunt for deer and we're fine. But if I take my spear and Ben takes his rabbit trapping kit, then I'm going to go hungry because I won't get a deer and I won't get a rabbit, but he'll get a rabbit. So he's sort of played safe. He's decided not to cooperate with me.
Sounds like me.
Yes. Yeah, I won't go there. It's usually hunting for Guinness, isn't it? So those circumstances require knowledge of your potential collaborator, and you need to decide whether you're going to trust them on the basis of your history of interaction with them. And these things are extensively studied. So there are strategies that people use. So for a long time, it was thought that a tit for tat strategy was the best strategy for doing that, and what people used, which is where I keep trying to use, if I'm playing tit for tat, I keep trying to use my go for the stag until he decides he's going for a rabbit, and then I'll go for a rabbit, and then this is actually works better in Prisoner's Dilemma, and then I go back to trying to use the hunt for the stag immediately and hope that you'll return. So it's kind of tit for tat. But then there's other strategies like win, stay, lose, shift. So if it doesn't work, you change your strategy basically. Otherwise, you stay. So again, there's this strategy space, and in order to play these, there's a whole set of games, not just Stag Hunt, but in order to play these games well, we need to adapt our strategy to the people or machines with whom we're collaborating. So these more social settings will require machines that understand those collaborative utility functions. Now, there are also variants of those games. So there's one-shot games, there are iterated games, there are grid world variants. So in a grid world variant of the Stag Hunt, you get some information about what your potential collaborator is doing as they move through the grid. You say, well, he looks. I think he's going for the stag. Is he going for the stag? I think he's going for the stag. And so you might say, yeah, I think he's going for the stag. So then you align and try and go for the stag as well. So that's more like the real world, where the information is kind of revealed slowly. And of course in human collaborations, we trust people, sometimes to our cost. Generally, you don't get very far in life if you don't have some capacity to trust, but it doesn't always work out. And sometimes you do get defectors who abuse your trust, and you learn from those as well.
I think that's definitely a place to build on as well when it comes to, when you're increasing the numbers of collaborators that you have within those social contexts, as well as the different types of agents, I suppose, that you might have. So when you have agent human different configurations, I think that's an interesting way of framing it when you're looking at Prisoner's Dilemma and we're looking at those types of tasks. I think that's an interesting way of focusing through it.
Yeah, good. So here's just remembered another idea. There's some fascinating work on trust in in psychology and economics. I think this is some of the most interesting science that's been done in the last 20 years on trust, and you really should read about it. So, and the particular thing you should read about is reciprocity, right? And so if reciprocity is if I scratch your back, you'll scratch mine, right? Hopefully. Right?
What now?
Just stay away. Not again. And that's called direct reciprocity, right? Where it's one-to-one, right? So Ben and I are friends. We've got a history of helping each other out when we're in trouble. I won't mention the particular cases. And so I know that I can trust Ben. Ben knows that he can trust me, right? And that's easy. But societies are not built on direct reciprocity. They're largely built on what's called indirect reciprocity. And so that's the idea that that there's a level of trust in a community that we're aware of, and that so a person may have this is formalized in terms of what's called an image score. So I might say, okay, Ben, I need to work with someone in the room. Who can I trust? And then he might say, Bob is really, really, really good. You should work with him. And I trust Bob because Ben trusts Bob. And I might say, well, Ben, why do you trust Bob? He said, I don't know. I've never interacted with. Why do you trust him then? And
he looks trustworthy.
He looks trustworthy, and he might say, no. X and Y told me, or I saw that X and Y have interacted with Bob, and that seemed to be working well. So there's this propagation of trust information, largely through gossip, actually, but within our communities, and that's how we build communities. So it's a community is essentially is a I would say it is a trust sharing mechanism through which we're able to jointly perform tasks that we could not perform alone. And that's extraordinarily important. And those ideas in the research are formalized well enough that I believe you can build them into the sorts of models that I'm talking about, so that you can build models that understand the trust mechanisms that work to build communities, human communities. And so it could even be the case, you could build an agent. This would be a great PhD project. You could build an agent that works in a community to elevate the level of trust by sharing information about reciprocal action, maybe.
Well, and this gets me on to my final question before I go on to the questions from the audience. Is that so? With collaborative AI, do you feel that we'll ever get there in terms of having that true collaboration that we experience in terms of a natural way with other humans, or will it be something different? Will it be something different as an experience?
I'm definitely very positive about the future of AI and machine learning. I think it's taken an entire lifetime for me. I thought it was going to happen 20 years ago, but what we're seeing right now is a historical turning point in the contribution that AI will make to society. I believe that. I think we can harness it to build stronger communities. I think we can harness it to work with machines. I know I'm not quite directly answering your question. Maybe I will do it by the end. But I think one of the things that's crucial is that humans stay in control. And this isn't about some future possible threat. This is about what major corporations are already doing. It's not about the Terminator robot. It's about what Google and Facebook already do to us. They are deploying AI systems to increase their profits. Period. They're not doing it for the good of humanity, and we can only take back control by keeping humans in the loop and by building. Not by destroying the machines, but by building machines that work with us for our benefit.
That does answer the question. Yeah, very much so. Right, I'm going to go to the mirror board just now. Then, so there are a few questions on here. So, So one of the questions is, what in your opinion is, how users should view collaborative AI, such as seeing it as a tool or a helper? It touched a little bit on the final question I was asking you there about whether we'll get there with collaborative AI. If we get there, what kind of role do you feel collaborative AI will take in interaction? Will it be a full collaborator? Will it be a helper? Will it be just a tool that's being used? Or will it be all of those?
Or a sort of a mentor, a sidekick.
Yeah.
What was that?
That's just a collaborative AI telling us the answer. We just couldn't understand it.
A machine, just a machine that helps you reveal your better self. That's what I'd like it to be, and that's a long journey to get there, right? So it's that self-actualizing objective on that last slide. It's something that allows me to be freer, to fully exploit who I can be for the better. That means maximizing my sense of agency. It means not being a drone in anyone else's definition of the world. That's what I want.
Thanks so much, Andrew. I really enjoyed that chat. Again, don't forget to review and follow us, and if you want to get in contact with us, you can by emailing us at humaninthemachinepodcast@gmail.com. All that's left for me to say is, I've been Ben Cowan, stay curious, and don't let the machines get you down. Until next time.